To date, astronomers have discovered nearly 500 exoplanets. These are planets outside of our solar system, orbiting other stars. So far, most of them have been very large Jupiter-sized worlds, gas giants with diameters and masses more closely resembling a star than a planet. As our techniques for finding exoplanets improve, we've been able to detect smaller and smaller worlds. Recently, astronomers have found several planets that are less than 10 Earth masses. These have been commonly called super-Earths, and while they are candidates for finding life elsewhere in the galaxy, they are not ideal. The holy grail of exoplanet research has been the detection of Earth-sized planets orbiting in the habitable zone of stars. Astronomers defined a habitable planet as one that is close to the size of the Earth and that lies within a distance that allows for the presence of liquid water. In late September 2010, astronomers announced the discovery of just such a planet. Gliese 581g, a rocky planet 3 times the mass of the Earth, orbiting just 17 million miles, 27 million kilometers, from its home star, revolving in an orbit with a year of only 37 days. The parent star of this new planet has been under survey at the Keck Observatory for over a decade. It is an M3V dwarf star, lying a distance of 20 light-years away from us. It is a cool star, its photons bathing all of its planets in a red glow. It is much, much smaller than our Sun, containing only 0.3 solar masses, 30% that of our star, and only 1% as bright. Because of its cool temperatures and small mass, the habitable zone of Gliese 581 lies much closer than ours does from our Sun. The Earth lies 93 million miles, 150 million kilometers from our Sun. Orbiting our Sun at this distance, liquid water is possible. At Gliese 581, that distance is only 14 million miles, or 22 million kilometers. Much, much closer. Gliese 581 is home now to at least 6 worlds, each orbiting the star at 3.2, 5.4, 12.9, 37, 67, and 433 days, respectively. Of these, the 37-day planet is the most intriguing. It is measured to be 3.1 times more massive than the Earth, with a surface gravity of between 1 and 1.7 times that of our home planet. We would weigh up to 70% more on Gliese 581g. What's more, the orbit of the star matches its rotation rate, meaning that one side of the planet is always facing the star, while the other has a perpetual view of the night sky. While this may have an effect on its habitability, it is still possible for life to exist in such a place. There are many factors that affect habitability. The distance from the star is but one of these. A planet may not have formed or retained any water. Gravity may be too weak to hold an atmosphere, or a planet may have accreted a massive hydrogen or helium envelope, keeping the surface pressure too high to prevent water in liquid form. Another important factor of habitability is surface temperature. The temperature on Gliese 581g, if we assume a greenhouse effect similar to that on Earth, is a cooler 245 Kelvin, minus 19 Fahrenheit, and minus 28 Celsius. Gliese 581g easily meets the requirements for habitability. With the surveys done so far, we now know of 2 habitable systems in our stellar neighborhood, Gliese 581g and us. It is extremely remarkable that we have found such a planet so early in our search. If confirmed by independent observations, Gliese 581g would be the first world ever found where life could actually exist besides Earth. Finding a habitable planet this soon among the few hundreds of stars in our local neighborhood has important implications for the number of habitable systems in our galaxy. It implies that either we were incredibly lucky, or that there are many more habitable systems than we ever thought. Of the 100 billion stars in our galaxy, up to 20 to 30% of them may harbor at least one habitable planet.